Hi, so before we go any further, let's get to know what is gravimetric analysis. So gravimetric analysis is actually a quantitative chemical analysis method that measures the mass of an analyte or its derivative to determine the concentration of a substance in a sample. So usually gravimetric analysis are usually being used widely, but today we are going to focus in food industry only. So there are some applications of the gravimetric analysis in food industry, which is first is a purity analysis, which is we are going to determining the purity of a sample by measuring the amount of a specific component, and then also moisture the content determination, which is gravimetric analysis used to measure the moisture the content in food products. Also fat content measurement, which is gravimetric analysis, are used to determine the fat content in food products. And also quality control, which is we ensuring product consistency in manufacturing process by using gravimetric analysis. So since gravimetric analysis are used widely, so that means it has a lot of advantages, and one of it is high accuracy, which is gravimetric methods are highly precise due to the direct measurements of mass, and also simplicity. The techniques involved are straightforward and do not require sophisticated instruments, and cost effective, which is requires minimal equipment and making it economical. Applicability, because gravimetric analysis can be used for a wide range of substances and in various fields. And last but not least, definitive result. This gravimetric analysis provides an ambiguous result due to the fundamental nature of mass measurements.
Gravimetric analysis comes in four basic forms, of which there are two typical kinds that include altering the analyte phase to separate it from the remainder of a mixture and cause a mass shift. Firstly, we have precipitation gravimetry. Precipitation gravimetry incorporates a precipitation process into a solid to separate one or more components of a solution. The precipitating agent is the substance that causes precipitates to form in the precipitation reaction. For example, the reaction between aqueous solution of a sodium chloride and silver nitrate yields the white precipitate of silver chloride. In this method, sodium chloride is used as a precipitating agent. Secondly, volatilization gravimetry. In this process, components of a mixture can be separated by heating or breaking down the sample chemically. Volatilization gravimetry can be used to separate various volatile gases such as carbon dioxide, chlorine, and other substances that are readily evaporated. For instance, sodium bicarbonate and carbon dioxide gas molecules can be separated using an aqueous solution of sulfuric acid. Carbon dioxide is a volatile gas. Next, electrogravimetry. The technique of electrogravimetry is used to identify and measure the ions in a material, often a metal. The analyte solution is electrolyzed in this procedure. Analyte is deposited in the cathode as a result of electrolytic reduction. The reaction illustrated below, for instance, might be utilized to pad out cadmium metal from solution using this technique. Lastly, we have thermogravimetry. It is a thermal analysis technique that measures material changes in chemical and physical properties as a function of temperature or time. A typical thermogram is depicted in the figure below, where each mass shift or step in the thermogram signifies the loss of a volatile component. A thermogram can be used to determine the breakdown reactions of a substance, as the example shown below.
Now, let's conduct a simple experiment of gravimetric analysis, which is the determination of total solids content in milk. What is the objective? The objective is to determine the total solid content in milk using gravimetric analysis. The apparatus and sample used in this experiment is milk sample, analytical balance, drying oven, desiccator, crucible, pipette, and hot plate. Before conducting the experiment, please be cautioned that We have to ensure accurate measurement to improve the precision of the results, handle crucible with tongs to avoid contamination and errors in weighing, and consistency in sample volume and drying time is crucial for reliable result. What is the procedures? The procedures of the experiment is, first, the preparation of crucibles. Crucibles are cleaned and dried by heating them in a drying oven at 105 Celsius for 1 hour. Next, crucibles are then cooled in a desiccator to room temperature, and each crucible is weighed using the analytical balance and the weight is recorded. The next procedure is sample preparation. By using a pipette, 10 ml of the mixed sample is transferred into each crucible and the volume used is recorded. Next, the procedures of evaporation. First, place the crucibles with the mixed sample on a hot plate. By using a hot plate, heat it gently to avoid sputtering until the mix was visibly dry. Next, transfer the crucible to a drying oven set at 105 degrees Celsius and dry for 3 to 4 hours to remove all moisture. The last procedure is cooling and weighing. After drying, transfer the crucible to desiccator to cool to room temperature and weigh each crucible with a dried mixed sample. So, let's go to result and calculation. For the result obtained, weight of empty crucible is stated as 50 gram and weight of crucible with dried mixed solids is 50.800 gram and volume of mixed sample is 10 ml. What is the formula? The formula used in this is weight of solids equals to weight of crucible with dried mixed solid minus weight of empty crucible. And next, the formula for determination of total solid content as a percentage of the original mixed sample determined by total solids in the sample by percentage equals to weight of solids divided by volume of mix and then times weight 100. How to calculate them? So put each value in the respective formula and then count them. So for the weight of solid, 100 gram minus weight 50 gram equals to 0.800 grams. And the second one, to determine the total solid content in mixed sample by percentage, is by 0.8 gram divided by 10 ml times with 100 and you get 8%. So by the gravimetric analysis, you can define that there is 8% of solid contained in the mixed sample.
In a nutshell, gravimetric analysis is a method to measure the quantity of analyte based from the mass of the solid form. It allows us to measure the purity of the product, the amount of specific ingredient, or even detect dangerous substance in a product. By measuring the specific ingredient, we can determine whether the product is healthy and can be sold publicly or not. This is very crucial to ensure that all of the ingredients in the product are healthy and approved by the Ministry of Health. Overall, gravimetric analysis is a very crucial method in the food industry. It is one of the most accurate measurement techniques and can be used in a large scale, and not to mention it is quite easy compared to the other techniques. Ultimately, food industry will require gravimetric analysis before releasing the final products for the benefits of the community.